Hi everyone, welcome back. So Leetcode problem of the day, daily question today is walking robot simulation. So a robot on an infinite XY plane starts at point 0, 0 facing north. The robot can receive a sequence of these three possible types of commands. -2 means turn left 90 degrees, -1 turn right 90 degrees, and 1 k is equal to 129. Move k units forward, 1 unit at a time. Some of the grid squares are obstacles. The ith obstacle is at the grid point obstacle I xi. If the robot runs into an obstacle, then it will instead stay in its current location and move to the next command. Means if he encounters an obstacle, he will not move forward and he will just move for the next command. So we have to return the maximum Euclidean distance that the robot ever gets from the origin squared. If the distance is 5, we have to return 25. So it just means that Euclidean distance is square root of x1 minus x2 whole square plus y1 minus y2 whole square. So we have to return the square distance, means we will not perform the under root, and the distance is from the origin, so it will be just x1 square plus y1 square. So this is the maximum Euclidean distance that we have to return, and the constraints are 10 to the power 4 commands, and the k will be 10. So maximum, if we see, if we move k for every command, k is equal to 9 for every command, then also it will be 10 to the power 5. This means that we can just brute force or apply all the possible movements and we will not get TLU. So that is what we will do. We will just perform the simulation as the question says. For each point we will check whether it is obstacle or not. If not, we will move forward. If we have to turn or change the direction, we will change the directions. This is what we will do. So first thing, the next thing is there are obstacles that also 10 to the power 4. We will have to search whether our current coordinate is an obstacle or not. So search time also we need to reduce. If we have to search for every command in the obstacles array, it will take a lot of time. We have to optimize it to O1. So we will just store the obstacles in a hash set, which will reduce the search time to O1. And hash set must search all those obstacles. We have two coordinates x and y. So we can store them in a string format, x space separated y. So this will help us to optimize the search time for each coordinate in the obstacles array. So this is the things we have to do. And initially we are at 0, 0 facing north. So if we remember the map, north is on top, and after that east is on right, south is on bottom, and west is on left. So these are the four directions. So we also need the directions and the index, the direction which we are currently on. If we are turning 90 degrees right, means we will be moving north, right, south and west. If we are turning 90 degrees left, means we will be moving north, west, south and right. Okay, so we need to do these also. So how shall we store the directions? As we have done in previous questions, we will store directions in a direction array. It is a 2D array which will tell how our coordinate will change. So first we have north. So north will be, for moving north, our y will change by 1 for each one unit, and x will remain same, that is plus y direction. See, nodes are given to us. After north we have east. For east, x will be increasing in plus direction, so x will increase by 1, y will remain same. Then south is minus y direction, so x will remain same, y will decrease by 1. And west means minus x direction, so minus 1 for x and y remains the same. So these are the four directions, and this will be cyclic, and our index originally will be 0. So now our direction change is very easy. If we turn towards left, means we will subtract it by 1 and do the Absolute means turn it into a range from 0 to 4, means we will mod it, and if we are moving right we will add 1 and mod it. So after when we reach 4 we will turn to 0. If we reach from 0 to left we will be reaching 3. So this we will manage using mod. Now the next thing that we had to do was store our obstacles in a hash set. So we have created a set of strings. We will store each obstacle in a string format: x coordinate space separated y coordinate. So now each obstacle from obstacles array we are adding it to the obstacles hash set, x coordinate plus space plus y coordinate. So this will help us to optimize the search time. Now we just have to brute force all the commands. We just have to simulate the situation. So initially our direction is north, that is we are on 0th index. Our x is 0 and y is 0, means we are on the origin. Now we have to find out the maximum distance at any point from the origin. So initially it will be 0. So now for each command from commands array we have to take, we will store it in k for each command. Now we have to check if it is direction change. If it is -2 means we have to turn towards left. So to turn towards left and to keep it in the range, what we do when we are subtracting, we subtract our value and add the mod. And here the mod is 4 because the array size is 4. So we will just add 4 and mod 4. This will always keep it in range 0 to 3. So this is what we do for modulus to keep it in range when subtracting. We subtract a value and add the modulus. If it is already in the bounds, this mod 4 will be 0, so this will not create any problem. So if it is 0, 0 minus 1 is -1 plus 4 is 3. So for 0 index it is working fine. If it is 1, 1 minus 1 0 plus 4 is 4, 4 mod 4 is 0. So again it's working fine. So this is how you handle cyclic processes, cyclic cases in programming for subtraction. And next we will see when we are moving towards right for addition. For addition we will simply add 1 and mod 4. So if we reach 4 we will be turning back to 0, that is to north. So our directions are working fine: north, east, south, west for moving towards right, and for moving towards left, north, west, south, and then east, and then again north. So this is how our directions are managed. Now the next command was directions. We have seen turning left, turning right. Now we just have to move the unit forward. So else it is a direction moving forward call. So what we have to do, we have to execute it k times. So k minus minus greater than 0. We have to move one for each k, we have to move one unit forward. So we will calculate new x and new y. How will we get it? Our current x plus the direction x coordinate means how much units we have to move, whether we have to add it or not. The direction will give us the unit in which direction we are moving forward. So if it is north we will get 0 in x direction, this direction 0 0, which will give us 0. If we are moving towards north, then direction for north 1 will give us 1, means we will add 1 to 5. So this will give us the new coordinates. Our direction array will give us the direction which we have to move, and we will add it to the original coordinates, so we will get new coordinates. Now we will have to check whether new coordinates are obstacle or not. So if the obstacles array contains that, that means we cannot move further forward, we will not change our current position, so we will just break out of this loop. If it is not an obstacle, our current position will change to new position. So our x becomes new x and y becomes new y. So when a command is executed, we have reached some position, so we have to calculate the maximum distance. So we will calculate max is equal to math.max max comma Euclidean distance. I initially told in the video it is x into x plus y into y, because we have to return squared distance. So this will give us the maximum value. So at last we have to return max. So this was the simple solution for this problem. I hope you guys would have got the approach. Thanks for watching the video. If you have liked it, please like, subscribe, comment, If you have any suggestions for improvement, please comment so that I can see them. Thanks. Have fun. Bye.